Today we will prepare the data to train a classification model using XGBoost algorithm and a Sagemaker. Okay, so here we are importing a bunch of libraries, the pandas for working with the data frames. We are going to access the data using a sklearn library, and we are going to split the data into train and validation using train test split, and IPython display. This is for just displaying the images. Now we don't need the Boto3 and logging libraries for this data preparation, but without so the notebook, if you are going to execute any commands related to AWS, it's going to say the found credentials in this AWS config file, right? So it's an unnecessary message. So in logging level, it's called info. So with this, what we are trying to do is we are telling the notebook display only the information if it is at least warning level, right? So with these 3 lines of code, we are simply suppressing the info level messages, right? Other than that, we are not going to use these libraries. Okay, so the data set we are going to work with, it's called iris data set. It's a flowers data set. Now, as you can see here, there are 3 variations of this flower called setosa, versicolor, and virginica. Okay, so these are the flowers. Now here we have this cartoonish representation where we can clearly see the differences. So the flowers have what is known as these petals and sepals. They look different for each flower. Okay, now the petal has a length and width. Similarly, the sepal also has a length and width. Okay, so as you can see from this cartoonish image, the sepals are generally longer. So for example, this one and this one, these 3 and also these 3. So they have this this distinctive structure in the middle. Okay, so that's sepal, and then the petal, it's this one and this one and this one. Okay, so what we are going to do is we are going to have a data with 4 variables: petal length, petal width, sepal length, and sepal width. Now, given these 4 variables, we are going to predict or classify which type of flower it is. Okay, all right. So from the dataset from scikit-learn library, here we are accessing the iris dataset. Now the data type is the scikit-learn this bunch. So it comes with a, in addition to the data, it comes with a bunch of methods. So here you can see all the methods using this direct dir iris. Now it has this description. So first let's look at the description. Okay, so we are looking at the description. Now the number of records is 150. The number of records, I mean the number of flowers. So a scientist, he went to the field and he collected these 4 metrics from 150 different flowers on the field. Okay, now as we discussed, we have 3 classes. So of these 150 flowers, we have 50 flowers for each class. Okay, again the data set has these 4 variables measured in centimeters, and then also has a class variable which is one of these 3 for each record. Okay, here we have some summary statistics, the maximum, the minimum of the sepal length, width, petal length and width, and we also have the mean and the standard deviations. Okay, all right, you can read more about it if you are interested, but that's pretty much about the data set. So now we are going to create the pandas data frame to prepare the data, right? So from iris data, it has these 4 feature values as we discussed. Okay, so here we are trying to create a pandas data frame with the iris data, and the column names are iris feature names. Okay, so at this point our data frame has these 4 columns with the values, and then we are adding the target variable called class using iris target. Okay, and here we are looking at the first 5 records of this data frame, and then iris has another method called target names. So here we have the 3 target names: Setosa, Versicolor, and Virginica. So in the class we have these numerics 0, 1, and 2, right? Whereas the target names are Setosa, Versicolor, and Virginica. So we can map 0 to Setosa, 1 to Versicolor, and number 2 to Virginica. That's because in machine learning model we work with only the numbers. So that's why these flower names are mapped to the numerics. Okay. So just looking at the data frame shape, so we have 150 records and 5 columns. 4 of them are features, and 5th one is the target variable. Now here we are counting the distinct values for each class, right? So okay, so class 0 we have 50 records, class 1 50 records, and class 2 also 50 records. So it's a very, very balanced data set. Now we are going to train XGBoost model inbuilt into Sagemaker. Now this model expect the target variable in the first column. So we are going to do a bit of data preparation here. Okay, so data frame dot columns, this will return all the column names. So we will have the 4 features as well as the target variable name here, as you can see here. So we are printing the columns, these 5 columns. Now we want to reorganize these columns so that we have the class first and the remaining features next. Okay, so here we are accessing the last element of this list, that would be class. Okay, and then here we are accessing all the names except the last element. Those would be 4 features. Okay, we simply reorganize these columns. Now they would look like this. Okay, first class and then the remaining 4 features. So here we are just recreating the data frame using the original data frame, but we are simply reorganized the columns. So now the data frame looks like this. Okay, so all we did is we move the class column from the last to the beginning. Okay, that's all we did with this code. All right. Now, so we are going to train a machine learning model. So that means we are going to have some training data. We are going to keep some data for testing or validation, right? So we are going to split this data. Now we are using the test train split method from scikit-learn library. This is the data frame. And we are saying, I want to use 33% of the data for testing. So for training, the remaining 67% of the data. Now the random seed, it's an optional variable, but by giving this variable, we can split the data in the same way. So for example, the records which go to train and the records which go to test will be the same if we are using the same random seed, provided all other variables remain the same. Okay. Sorry for that message. All right. And then the stratify, this is very important. What it does is, as we saw, we have 50 records for each class, and we are saying we want about 2/3 of the data for training, 1/3 of the data for testing, right? So for each class, it split the data such that we have 2/3 of the data in the training and the remaining 1/3 in the testing. Now, this data set is balanced, so it might not be that important, but whenever we have this highly imbalanced data set like customer churn or fraud detection, etc., where we will have highly imbalanced data sets, right? For example, if we have 10,000 customers, probably 9,900 of them don't churn. Only about 100 of the customers churn, right? So when we split the data, it is important that the rare class also split into train and test with the proportion we choose here, right? So if it is those 100 rare classes, when we do the split, about 66 of them goes to the train and 34 of them goes to the test. Otherwise, what will happen is among those 10,000, randomly 2/3 of the data goes to train. Now it might happen that all the 100 records or maybe 95 records might simply go to the train. So the test data set will have only 4 or 5 records from the rare class, right? So that's why it is important to stratify using the target variable, so that even those rare class records get distributed to train and test as per our split proportion here. Okay. So in this case, we have roughly 33 or 34 records from each class chosen for training, and the remaining 16 to 17 records for each class are chosen for validation. All right. And then we are writing the data to a file called iris_train. We don't need the index column. This is that by default, when we write data to a file using pandas, it creates an additional column with serial numbers 1 to n, right? We don't need that. And also we don't need headers. As we discussed, machine learning models, they only work with the numbers. So we don't need to give the column names to the ML model, right? And then we are creating the test data set. We are writing the test data set here. All right. And then we are going to do what is called batch transform, right? Where we give a number of, we apply the machine learning model on a number of records at the same time, right? So for that, we will have only the feature values, right? We don't have the target in the file, because that's what we are trying to predict. Whereas in these files, we need to have the target variable as well, so that from this file, the machine learning model try to learn from the features and try to map those features to the target variable. And with the test data, as the model training, it apply its learning on the test data to see how good it is performing, right? After the model is trained, then we do the batch transform. So by that time, the model has already learned how to map the features to the target variable. Now we want to test the model. So we will input only the feature values, right, during the inference. Okay. So what we are doing is, from the test data, we are simply dropping the class column, and we have created a new data frame called inferdf. So this will have 4 feature variables. Now we are writing this to another file called iris_infer, right? All right. If you look at our file format, this is how it looks like. Just printing the head are the first, I guess, 10 records from the files. So the train data file will have the target variable in the first column. This will either be 0, 1, or 2, mapped to 3 different classes. And then we have 4 different features. Okay. And for the infer also, so the test will also have same structure, whereas infer will not have the feature in the first column, target variable in the first column. So we have only the 4 feature values in the data file, right? And then now SageMaker expects all the data for training, validation, etc. To be on S3 storage, right? So we prepare the data set locally. Now we are going to upload the data to S3. So we are uploading the train data to this S3 path. So I already have created a bucket called Sagemaker course. And then I have this prefix iris/data. So we have uploaded the file, the training data file. Similarly, we uploaded the test data file, and then the infer data file, we are uploading it to another folder called the batch transform. Okay, so this is how it looks like on the, I'll show you in a second how it looks like on the SageMaker, S3 console. Okay. Now we don't need this, but I just want to show you one interesting thing. So all we are doing is we are simply doing the pair plotting between the four feature variables. Okay, four feature variables, and we have color coded the data so that we have different color for each of these classes 0, 1, and 2. Okay. Now let's look at only this the middle ones. Right here we have the histogram distribution of the each feature value. Now the sepal length and sepal width, they sort of overlap. There is a significant overlap in the distribution for different classes. Okay, whereas for the petal length and petal width, the distributions are there is no overlap. I mean, there is some overlap, but there is quite good separation, right? So what this means is, using the petal length, we can easily distinguish these three flowers. Using also the petal width, we can distinguish these three flowers. And especially this class 0 is very, very distinctive. Now sepal width and sepal length, it's hard because their distribution is overlapping. All right. Let's look at this. Let's look at in the images if petal is a better predictor or sepal is a better predictor. Okay, so if you look at the petal, yes, it is different. So for this flower, it's of this size. For this flower, it's like this. For this one, it's quite big, right? Whereas the sepal, for versicolor, setosa, and virginica, it looks very similar, right? For these three different flowers, sepal looks very similar. The petal is very distinctive. So petal should be a good predictor for distinguishing these flowers, which is what should we are seeing here. Okay. All right. Let's go to the SageMaker console. AWS bucket S3. All right. So this is the bucket we have, SageMaker course, and then we have Iris. We have a new folder for this project, and then in this data folder, we have the train data and test data, and then in batch transform folder, we have the infer data, right? So that's it. We have prepared the data, and in the next step, we will train a machine learning model using SageMaker inbuilt algorithm XGBoost. Thank you very much.